Our next session is I'd like to invite Adjunct Associate Professor in the School of the Biological Sciences in the University of Adelaide, and is a director of the not-for-profit group BioR, which is David Paton. David's interest in the Coorong dates back to the early 1980s, and for the last 25 years has been undertaken an annual census of the waterbirds and some of their food resources in the Coorong. So, yeah, we could give David Paton a big round of applause.
Thanks, Kevin. I should apologise for this title because I'm not here to lobby for a 1980s rock band to come and perform down in the Coorong, but it would be a hoot. But I have one song that sits in my mind, which is a bit of a theme I'm going to follow through this, and it just resonates with me. And that's that song, their hit song, which was Money for Nothing. And I'm going to try and illustrate how we spend money and we actually don't deliver the goods. I'm going to talk about the TLM and MDB plan. They're linked. I'm going to talk about two components. One of them is going to be the plants. I'm going to talk about them first, and we are to maintain and improve this rather unique, very resilient plant that lives in the southern Coorong and the hypermarine part of it. I'm going to talk about that first, and then I'm going to just talk a bit about some of the bird stuff. So, to really understand the Coorong, we need to understand the salinities. And once you have an understanding of the salinities, it makes you think about how to manage this system and what you should and shouldn't do to it. So, the northern part of the Coorong is largely estuarine. And this along the bottom is just distance from the Murray mouth. Seawater's there, and this was back in 2000, before the Millennium Drought, before any sort of drainage scheme coming into the Coorong from the southeast. And you'll notice that the salinity gradually increases, and there are 4 lines shown here at different times of the year. The typical winter levels are shown in green, summer too, but in spring the salinities are lower, and at the end of summer, in autumn, the salinities are higher. And the salinities at the southern end are consistently hypermarine. In fact, they're almost consistently twice, if not 3 times saltier than seawater. It's a regime, because it changes a bit from one year to the next, but it changes seasonally. Now I want to just show you a little bit of data for the summertime in recent years. And what we've implemented here is a drainage scheme into the southeast. And yeah, many years there's still that gradient, but there are also dips in those salinities as you go south, and you don't maintain that salinity gradient. And you need those hypermarine systems to have various components in this Coorong system. And one of them is Ruppia tuberosa, and it's unique in that system. And how well is it faring in a system where we're manipulating it by changing the salinity regime that it might normally experience? So what is Ruppia tuberosa? It's an annual plant. Just showing you the flower stalks there, but you don't see those very often in the Coorong, not nice and healthy ones like that. It grows on the ephemeral part of the Coorong, so with those salinity changes, there's actually changes in water level. At the southern end, it's probably up to 1 metre change in water depth. And so for parts of the year, typically in autumn, it's left exposed. It then has to germinate or sprout from other propagules, known as turions, and grows through the rest of the winter and the spring and into summer before water vanishes again. Water depths are usually between 0.3 and 0.9 of a metre. It can't grow in deeper water because the water's usually too turbid. Can't grow in shallow water, it can, but it never gets through to reproducing because day-to-day fluctuations in water level get to that 0.3 of a metre levels at time. Plant doesn't perform well. And it will grow in salinities in the Coorong anywhere between 50 and 110 grams per litre. In fact, you can find it alive in salinities as much as 200 grams per litre. As I said before, a critical part of its existence is that it has to reproduce regularly. It does it through asexual means, produce seeds, and it does it through asexual means, which are by producing a bit of tissue, which we refer to as turions. You can think of them almost as little potatoes. So there's a whole range of things that we use for that, and when we first started designing the actual management and the monitoring of this and trying to give someone some idea of how well it was performing here, we had some very simple things. If you want to maintain this plant, then it should be able to maintain its distribution within its previous and known extent of occurrence, and that happens to be about 43 kilometres. It can be higher, but it shouldn't get less than that. Its area of occupation means that sampling sites within that area, that extent of occurrence, 80% of them should carry the presence of just a plant is enough for you to tick off on that. That's not hard to deliver, given the plant grows almost like a lawn and has merely 100 shoots at times when it's healthy. The next two components are a little bit hard to deliver. What is a vigorous population? I'll come to that in a minute. And also something about its resilience. Having a set of seeds present that enables it to live through adversity and come back even after a couple of false starts. I'm not going to spend too much time on the bottom two, but let's just, I'll explain them first though, and then just forget about them. Other than I'll cover the first one. One of them is that to be vigorous in any place, take a whole lot of cores, at least 30% of those cores should carry shoots. Second, the density ideally should be at least 10 shoots per core. These are conservative. Normally you have 100, really healthy pop, 100% of cores and up to 100 shoots per core. Property densities, I won't really deal with those, but there's also measures for that. And all of them are set well below what might be a truly vigorous population. And the thing about future resilience is having sufficient seeds to get you through there. I can tell you right now, this plant's never got close to reaching its resilience. The coring is pretty straightforward. The water's murky, you don't have to do too much. We normally take 25 cores, approximately a metre apart, pull the core up, painstakingly count the shoots. I love it when there's no plants there. Doesn't take long to count. Then we sieve it and score the seeds and turions and so forth. And for those who don't know, that chap there's Colin Bailey, who used to help me a lot. But let's have a look now at a sequence of years, at a sequence of sites within the extent of occurrence, and see how this plant is performing. And I suddenly realised that I did red and green, so I apologise for the males who might have red-green colour blindness and not be able to distinguish red dots from green dots and so forth, but I've made the red plus stars, and they represent places where there were no plants. And the other dots, as they get bigger and bigger, represent a more substantial population. It's the percent of those cores that carried shoots. And you'll notice in 2017, pretty good, covers the extent of occurrence. In 2018, it's much the same. Some changes in the abundance there, a few sites not having it, etc., through to 2020. And let's now look at the next 4 years. Reasonable in 2021, reasonable in 2022, reasonable in 2023, and in 2024, this plant species, a key characteristic of a wetland of international importance, has been obliterated. Lots of explanations for why it might have happened, and people will come and keep proving it, but whatever happens, that is a whole of basin reportable, which clearly shows we're not meeting a very simple task of just maintaining the plant within its extent of occurrence. What might cause those things? Let me talk to you about some of the problems this plant now suffers. How many have actually seen these plants? This is what the flowering stalks look like. And these plants flower by putting up a spiral stalk, and then they sit on the surface of the water, And I'll just go one forward through, but I think I've actually lost an image there. No, there's the male flowers. The male flowers, the inflorescence starts the male flower, it sheds its pollen on the surface of the water. Very hard to do in the Coorong if you've got water going up like this all the time. But the little spiral thing just extends and shrinks, extends and shrinks, so it keeps the floral head on the surface. They start as male flowers. Little immature female flower is just visible there. I think there's a couple of inflorescences within each of these flower heads. I'll go back to show you the female heads, and that's what the plant has to do for reproduction. Now, the real problem for this plant is that in the Coorong, and in the southern Coorong where this plant occurs, and I've been going down there, believe it or not, since the 1980s, early 1980s, I've got a 40-year record and connection to that place, and I monitored Ruppia tuberosa with the same sorts of methods. I did it again in the 90s. Never saw algae affecting these plants through those periods, nor during the first decade or so. It was only around 2012, 2013 that one started to see algae appearing. And the algae attaches to the floral heads, it increases the drag, and it just rips those flowers off the plants. And they fail to reproduce. Now that occurs when the salinities are 70 or 80 grams, and it's been happening for a number of years. I just want to show you in 2021, spring 2021, the salinities are around about 70 or so grams per litre. Plant survived, good cover, etc., but it failed to reproduce in terms of producing seeds. The challenge is that in spring 2023, the salinities were all around about 50 grams per litre. And at those salinities, you'll get algal blooms, significant algal blooms. They don't just stop the plant from actually flowering, they actually prevent it from surviving. And you'll get images like this around the Coorong in springtime. Now we're in all debate where the nutrients come. But in the 1980s, 1990s, the proposals to drain water from the upper southeast into the Coorong, and in all of those reports, they highlight there is a risk that this water going in could carry nutrients which could lead to algal blooms. And any program putting water in needs to be aware of that risk, particularly for a wetland of international importance where a key component of it might be eliminated. But did we take a risk-averse approach? No. What we've actually done is to actually increase the volumes of water going in. From 2018-19 onwards, there was a southeast drainage proposal, which finally got implemented. And that drainage proposal now puts a much greater volume of water. It does two things. It dampens and changes the salinity, tipping it to favour algae by being lower, and it almost certainly just keeps adding additional nutrients to the system, adding to the impact that it does. And this is that drainage scheme. And you know, I have great debates with people saying, oh no, there's no nutrients coming in. It is obvious to me there are nutrients going in. You can see the algae growing in the actual flows going out. Let's now just go back to that scoring board. And so, you know, I rarely had a time when you would not reach the top line. The target is 43 kilometres spread along that South Lagoon. In 2024, the 4 places where there were plants were no more than 15 kilometres apart. I can assure you those plants are now high and dry because water levels have dropped since January. This is just in January, but they are probably no longer there now. Area of occupation, yep, you've got a few spots within that area, within that extent of occurrence, 21% of the area has it. The vigour, the resilience, gone. It's worse than that, because when you look at the propagule banks, normally you would get some turions produced by these plants. And the yellow lines shown here is the sort of a relative amount of turions, And 99% of the plants that re-establish in the winter when water comes back over these ephemeral plats come from turions. In 2024, negligible turions. This plant has gone from the system and is unlikely to come back in a hurry. Let me conclude this part of the talk. I'll say Ruppia tuberosa was the key characteristic of the Coorong, a wetland of international significance, and listed in it. It has been eliminated because of inappropriately low salinities coupled with nutrients, has negligible capacity to recover, and these changes in ecological character, I have no qualms, were both predictable and preventable. Continue to release water at Salt Creek just exacerbates any chance of recovery. Those releases, therefore, should cease. Those releases of water at Salt Creek should never have been proposed or approved as an SDLAM, as Richard talked about. The sustainable diversion limits. What do? It means you can put water down the bottom end of the Coorong so you can keep more water being extracted out of the river and trash. And I say trash, a wetland of international significance on which the very legislation for the Murray-Darling Basin Plan is based. We have failed to maintain, let alone improve, Ruppia tuberosa in the Coorong, and from my perspective, the Coorong is far from healthy or resilient. Let's change tack. What about those birds? How have they been faring in this system? I do an annual count. It's tedious, it takes a long time. I use a team of people to help me, but it involves systematically counting the birds in a series of 1 kilometre wide transects across the length or up the length of the Coorong. There's about 110 of them. There's probably 6 to 8 days of actual field time. And those systematic counts are known as a census, and we can look then at how the changes in bird numbers in this region have changed over time, and particularly recently. So, waterbirds primarily use the Coorong as a summer refuge. This includes migratory shorebirds that come to the southern shores in our summer to avoid the harsh winters in the northern hemisphere. It also includes a whole range of other endemic waterfowl and so forth within the country. There are some exceptions. There's some species which come there and breed, but various fish-eating species breed in the system as well. The numbers fluctuate from one year to the next. Makes it very hard to simply jump to inclusion after 1 year. So I'd actually try and find a way of solving that. But the notion here is the TLM goal was to actually maintain or enhance, and it would increase the abundance of birds, particularly as this is after the millennium drought when birds struggled in that area. Now I'm going to show you a series of tables, and in those tables I'm actually going to compare the January counts for a number of years against a long-term median. It's not really the long-term median, because the long-term median would be much higher, but it's the median number of birds present for a 16-year period between 2000 and 2016. Now, if you are maintaining the numbers, then you'd expect them to have at least half the time they should be above that median value and no less than half below. And if you're increasing it, then you'd expect it to be primarily birds sitting above that median value. I'm going to use, and apologies again for people with red-green colour blindness, indicate when abundance is median, and red when they're below that median, etc. And we're just going to deal with the groups of birds, and all you have to do here is to look at the colours and get a feel. The first group of birds I'm going to deal with are waterfowl, swans and ducks. And most of those are looking green, and we could be pretty comfortable with that, a few red spots, no concern. Various fish-eating species, pelicans, cormorants and so forth, all doing reasonably well, probably arguing they're maintaining their numbers. Other fish-eating species, much the same. And then we come to the shorebirds. These are the endemic shorebirds, things like red-capped plovers, oyster catchers, avocets, and these are nearly all red. These birds have failed to maintain their abundances. And likewise for the migratory shorebirds. And they're actually pulled out as a key component, some of these migratory things in the whole of basin reporting. I want to give a summary to this. Herbivorous and fish-eating birds have generally maintained their numbers. Herbivorous waterfowl, however, are currently forced to eat algae, and their prospects of maintaining their abundances when you've lost a key plant, Ruppia tuberosa, will challenge them in future years. But of greater concern, migratory and endemic shorebirds have continued to fail to maintain their abundances. My concluding comments are these. The Coorong is not healthy. Its health is dire. The slogan, healthy Coorong, healthy basin, is grossly misleading. We have actually spent money for nothing gained. And I'm going to make it very clear that we are all culpable. Thank you.